Oh, I don't know. Who has done this? Normally, after every session, these office people. Okay, this is recording now. Is it audible now? I can hear now. Okay, thank you. Let us start now. Okay. So, you are there in the last class? Online? You are not there in online also? The first class you are attending? Huh? No, last Saturday? Last Saturday I didn't see you. I think this is the first class you are coming. Okay. No, at least you are you in the lesson? Online? No. Oh, okay. Other you also? See, that is a problem here again for me. Because I think those who are there in the online, I think you people remember, and just to recollect what is discussed in the last class, I started as a multiple regression model. Okay, how to model a simple linear regression model and a multiple regression model. I'll summarize in 2 minutes. So that means how to find a relationship between the dependent and a variable and a set of independent variables. And first thing is that we have to develop a model with the help of the sample data. Okay, multiple regression model we have to develop first with the help of the sample data. After that, we have to go for validation of the model. That means whether the model is can be acceptable or not, we have to do the validation. How to do the validation? There are 4 steps are there. First one, you have to go for R squared value, that is a coefficient of determination. The second one is the overall significance of the model. And third one is the individual parameter significance checking. And lastly, the estimation part, accuracy, that is the individual, and then the correlation and all we can check. And in addition to that validation, of course, before developing the model only, we are supposed to check the assumptions. So model, linear regression model, you can't develop simply for the given sample data unless your sample data satisfies the certain assumptions required for regression. The assumptions are the checking for the linearity assumption with the help of the graph or with the help of the histogram. The linearity checking by the graph, then the normality of the errors with the help of the graph, that is through the histogram or a normal plot. And then we have to check the homoscedasticity, that is a constant variance of the error. Okay. So unless these assumptions are satisfied, you cannot run the multiple regression. So this is what we have discussed in the last class. Now, extending that one, the most important in any regression model, when you say the model, what is the model? Y is equal to beta naught plus beta 1 x plus E. E stands for error. Okay. So that means the dependent variable value not only influenced by the taken explanatory variable. Okay. Some other reason also may be there. See, for example, demand not only is affected by the advertising expenditure of the company. Suppose if I take, or not only affected by the price. So it is also based on some other component, some other variables which we are not considered in the study. So that may be considered an error. So we are interested to develop a model, let us say that between demand and price. So demand versus price. So we are developing a regression model. Y is equal to beta naught plus beta 1 into beta 1 x plus epsilon. So y is the demand, x is the independent variable, is the price. So apart from the price, some other influence also there on the demand that is considered or attributed as an error. So that error is very important. That is a statistical model. If it is a mathematical model, you could have taken directly as y is equal to beta naught plus beta 1 x. Now, after doing that developing of the regression model, validation, etc., you have to go for the next level of understanding. Okay, being a analytics, okay, analytician of the data, particularly with related to the regression model and all. Very important thing is analyzing the error. So that is called the residual analysis. So we have to do the residual analysis also. Residual is nothing but an error only. So These are all we have taken in the last class. Standard error of estimate. Okay. So this is what the residual analysis. So what is the meaning of the residual? What is the meaning of an error? So it is nothing but an actual value minus estimated value, y minus y cap. So the residual for observation, that is EJ or EI, is the difference between the observed value and the predicted value. So checking the assumptions of regression by examining the residual. Okay, for residual only we can check the assumption. What are those? The linearity assumption you can check, independency of the variables, independent assumption, normal distribution assumption, equal variance for all levels of X. That is nothing but the homoscedasticity, what I said. So these are the assumptions you can check through the residual analysis. How we can do that one? First one, graphical analysis of residuals. That means you can plot the residual versus X. So residual values will be there. Along with the X values, you can plot that one on the graph and you can see how the graph appears. Look at this one. Residual analysis for what? Linearity. Whether the data is a linear, residuals are linear or not. So suppose if you get the graph like this way, the plotted value is almost very close to the straight line, ups and downs, and here in this case. So this was a linear, here and here, it is a linear. Whereas here, it is not a non-linear because it is not in a straight line. It is somehow like a curvilinear. And here also like this one is going up, bending again like this way. So it is a non-linear relationship. So how to understand the linear relationship of the residual? Just by the plot. Okay. So if you understand the linear relationship, linearity of the residual, okay, obviously we can understand the linearity or linear relationship between the dependent variable y and the independent variable x. Next, residual analysis for independent. How to check the independency of the data of the residuals, whether the residuals are independent or not. In other words, variables multicollinearity we are trying to check. So if the residuals falls in this pattern like this way, when you plot it on a graph, or in this pattern, so it is not a independent. But if the residual falls in this format, in this pattern, you can do all these things through the SPSS or any other software. Okay, you cannot do it manually. SPSS will take care of all these things. So if it falls like this way, we can say that there is a independency. Where is the residual in the graph? Okay. So residual is nothing but that is a gray color only. That is a gray color falling above or below the line. So they are the residual. Okay. So I'll go back to the previous slide. Or even this slide also. So that gray color, this is a round mark, whatever we have done, there is nothing but the residual values only. So this is the x-axis, this is the y-axis, and to that we are plotting the residual. And this right side, two different types indicating the linear relationship, the left side indicating the non-linear. So that is about the linearity of the residual. Similarly, independence of residuals. That means whether the residuals like E1, E2, E3, etc. for different values of x, are they independent or not? How to check that residuals are independent or not? So you can go for again the graph. The left side indicating the not independent is the residuals falls in that format, and they are understood as independent when the graph shows the straight line and falling above or below that line. So there is an indication of independence of residuals. Yeah, see. We are not, these are the residuals we are plotting, not directly the direct residuals. What we are doing, we are converting the residuals into standardized values, standardized residuals, different types of standardized predicted values, residuals versus predicted value. We are plotting it. So if it graph comes like this way, That means the point shows in this format, they are not independent. Means residuals E1, E2, E3 are not independent. So there is some kind of relationship. That means some pattern is there. So when some pattern among the residuals is there means they are not independent. But here it is not like that one. So that is the case. Straight line falling above or below. So this is an indication of independency among the residuals. That is the standardized data I am talking. Next we have to go for what? Confidence interval and prediction interval estimation. So what is the difference between the confidence interval and the prediction interval? You can see the goal. Form intervals around y to express uncertainty about the value of y for a given xi. That means you are trying to find an interval for the y value. That is a dependent variable value around the value of given xi. So this is the xi value. You can see the graph. This is the estimated line is a y cap. This is the x value. This is the one particular value of x is xi here. It is intersecting at this point. And this point value is exactly this one, B0 plus B1 into xi. Okay, that is beta naught cap plus beta 1 cap xi, however you can call. So this is this point exactly. Now, the values falling above or below around that one, no? So that is taken as a confidence interval for the mean value of y. We are not exactly finding the interval for the y value. We are trying to find the interval for the y value, the mean interval. On an average, what is the range for y value for a given value of x? So exact value is this one, estimated value, but interval, exact value is not exactly equal to actual value of y, correct? So we need to find an interval for that one. So that interval is nothing but this difference. So this is called the width of the mean interval, mean of y, for average of y, so that is an interval. Then what about the prediction interval for an individual y given xi? See the difference. This is gives average interval for a mean value of y. That means for average value of y. What is the average? For example, in our case, demand and price. Y is a demand. Average demand interval. So that means the average demand may be this to this one. So that is called as a confidence interval for the mean of y. What about the another one, gray color interval I have given? That is a prediction interval for an individual y. It is not an average. So the interval value, that means the value of y for a given value of x may be between this value to this value. So that is a prediction interval. So you should know the difference between the interval for the mean value of y and the interval for the individual value of y. Just like to say, simple way, in the classroom, the interval for the average marks of students of a class. Okay? The interval for the average marks of the students of a class. When I say the average marks of the students of a class means whole class is included. So I am trying to find out the average marks interval. Let us say that the average marks of the class may be between, let us say, 60 to 75, 60 to 80. Individual means what? For any particular student. Okay, for a particular student, what is the interval of his marks? Lying between what to what? Okay, so that is called the prediction interval for an individual y. So in our example, the interval for the average demand. Another one is the interval for the individual demand for a different value of, for a given value of x. See, this plot is there. Just some points if you want, you can copy. Otherwise, this whole PPTs are available. You can copy, and it is already copied there on the desktop. Here only. So, how to calculate that? Confidence interval for mean value of y given x. Here I have given what is the meaning of that confidence interval I just shown. What is the expression for that? That expression, of course, is not needed for you because you are not going to remember that. But anyhow, as a part of course, just highlighted here. So confidence interval for mean value of y for a given x That is 100%, 100 into 1 minus alpha confidence interval. That is the mean value of, for mean value of y. So this is the interval. See, this is the estimated value of y plus or minus T alpha table value into standard error and so much. So if you take yi cap minus this value, it is a lower value. If you take yi cap plus right side value, if you take upper value. So the average value of y lies between that lower value to upper value with a confidence of how much? With a confidence of 1 minus alpha. Suppose if alpha is 5%, means 95% confidence. Suppose if alpha is 1%, 99% confidence. Okay. So that is how we have to calculate standard error. Anyhow, the formula is not needed, just highlighted. But what about the prediction interval for an individual value of y given x? The prediction interval estimate for an individual value of y given a particular x. Again, there also 100 into 1 minus alpha percent confidence. Means alpha is 5% means 95%, alpha 1% means 99%, if alpha 10% means 90% confidence, etc. So 95% I am confident. That means suppose if I take alpha 5%, I am 95% sure that the individual value of y for a given value of x lies between this value to this value. There is only 5% chance that the individual value of estimated value of y may be away from that lower value or away from the upper value. So what is that? How to calculate? Same thing, plus or minus the alpha. We can see only difference. That just one is a difference in the formula. 1 plus. Look at the previous example. 1 by n plus same thing. Only that 1 is left out. So if you add that 1, how it has come, etc. is not important for you. So the extra term adds the interval width. That is a 1 for individual value of y. So confidence interval in a regression model for two things. One is for the mean value of y. The another one is for individual value of y, for the given value of x. When x's are observed values of independent variable, yi is the estimate of yi, n is the sample size, and s is the explanation for that. Again, the example is taken. Okay. Suppose if I want, find the 95% confidence interval for the mean price of 2000 square foot houses. So this related to my earlier example only. It is a continuation. That example I have discussed in the previous class. Okay. That means what is the value of the house? Value of the house, and that means the price of the house depends on how much the square feet. Suppose higher the square feet size of the house, obviously price is more. So here, for the mean price of 2000 square foot houses, suppose if the house size is 2000 square feet, then what is the average price? Okay, for that how to find out the range? You can apply that value, predicted price, you got it from the previous model, and we are getting like this plus or minus. That means it is between $280 to $354 something. There is an average price for average price of the house. Okay. Suppose if you want the individual house price, there is a range of the individual house, then it lies between these two things. By adding, using that formula, 1 plus 1 by n, etc. Okay, so that is the difference. Average house, because let us say that in a layout in a society, there are many houses. Okay, so the almost all of them are, let us say that 2000 square feet house only. Then what is the average price? Okay, so that is the earlier one. What is the individual house price? So then this is what the formula. Small variation would be, you can see that the width of individual is higher than the average. The average was what? 280 to 354 something. But now the average, the range is 215 to 420 point something. So obviously that individual prediction range is higher. Okay. What is happening? Oh. Next. That is repeated again. That's why I skipped that. So that is what the regression analysis. Next one is what? Pitfalls of regression analysis. Whether it's a simple linear or a multiple regression, we should know. Because being a data analytics, it is how to say no. It is similar like A person learning riding a vehicle, okay, motorcycle, let us say. People, what they will do? They will ride the vehicle. That means they don't concentrate on other things. They concentrate only on what? Riding the vehicle. So that means they will learn how to change the gear, so the speed, but they will not be knowing very clearly that when to stop, how, in what pressure we have to stop. Otherwise, you know. So, and many more things like suppose if some problem happens, how to repair that one or how to overcome the problem during the time of traveling, etc. So, this regression is like this. Normally, everybody teaches for ordinary, for a class, what, how to, for a sample data, how to find the parameter, estimation of that model, how to write it, how to validation of the model, what is the meaning of the overall significance, R squared value, etc. That this is what the regression model. But being a data analytics, we need to learn something extra also. That more information about the regression is required. That means the assumptions we have to check for what are the important for developing a regression model. Then any drawbacks of the regression model. So unless you know all these things, you cannot effectively, you cannot develop a regression model which is accurate in predicting the value of y for a given explanatory variable values. So, and when you know all these things, I think we can develop a suitable regression model. So that is I have given as the last one, pitfalls of regression analysis. What is that? Lacking in awareness of the assumptions underlying the least squares regression. So if somebody ignores the assumptions required for regression model, that means he cannot develop a suitable regression model. That means the accuracy he cannot, accuracy won't be there. So lacking of awareness of the assumptions. Second one is what? Not knowing how to evaluate the assumptions. Like what I said, you know, what are the assumptions? How to check the linearity assumption, how to check the normality, how to check the homoscedasticity. Clear? How to check the multicollinearity of the variables in a multiple regression. So these are the minimum required assumptions. If analytics, a data analytic person, if it does not know how to evaluate those assumptions, so again, you cannot claim that the developed regression model is the best one for the given sample data. So that pitfalls, normally people won't do all these things. That's actually very, very important thing. First one is awareness of the assumption. Second one, evaluating that assumption. So if you don't evaluate, that is a pitfall of the regression. What is the next one? Not knowing the alternative to least squares regression. If all the points are satisfied, all the assumptions are satisfied, then we have a least squares method to estimate the parameters. So in the regression model, we have y is equal to beta naught plus beta 1 x1 plus beta 2 x2, etc. So where beta naught, beta 1, beta 2 are coefficients. They are the parameters. And they have to be estimated from the sample data. What they indicate, see for example, beta 1, beta 2, they are the slope values. How much for a 1 unit change in x1 variable value, how much the changes you can expect in dependent variable y. Similarly, for a unit change in the x2 variable value, how much the change in the dependent variable y. So we need to estimate those beta naught, beta 1, beta 2, etc. from the sample data. How do you estimate that? That is what they call the regression fitting model, fitting only. How to estimate that one? There are many methods are there. The most important and we are considering is the least squares regression method, means minimization of the error sum of squares. But that is applicable only when all those required assumptions are satisfied. So that is what the pitfall. So not knowing the alternatives to least squares regression, if a particular assumption is violated, suppose if any assumption is violated, then what is the alternative to find a regression model? Using a regression model without knowledge of the subject matter. Some people will simply use the regression model for every type of data without knowing what is that actually. So that is again a drawback of regression. People every predictive analytics means immediately comes to their mind the multiple regression model. And last one is what? Extrapolating outside the relevant range. See, the different values of x, estimate the value of y only to some extent. But if you go for outside the range boundary, it may not be correct to say that, okay, this is the estimated value of y for the given value of x. So, extrapolating outside the relevant range, that is applicable only within the relevant range only. So, these are the pitfall, or in fact, we can say more than pitfall, we can say these are the necessary things a data analytic person should know when you go for developing a regression model. So, how to avoid all these things? That is what. Once you understand that, okay, these are the possible pitfalls, then how to avoid all those things? Start with a scatter plot of x and y to check the possible relationship. Perform the residual analysis like what I said just now to check the assumptions, that is the linearity assumption, then normality assumption, okay, etc. Plot the residual values x to check the violations such as the equal variance, that is the homoscedasticity. Use a histogram, stem and leaf display, box and Whisker plot, etc. for checking the normal probability plot for the residual to check the normality. Okay. Now, if there is a violation of any assumption, use the alternative methods or model. If there is no evidence of assumption violation, then the test of significance of what we had understood in the last class, regression coefficients and constructive confidence interval and prediction interval. Avoid making a prediction or forecast outside the same thing. Whatever I explained separately as given as a consolidated information here. Okay, so that is about the regression model. So actually in the last class I stopped at this level. So in the last class I detailed, in the last two classes I explained how to construct a simple linear regression model and the multiple linear regression model, the difference between them, how to estimate the parameters, how to validate the model, etc. So I stopped there. The last part was the analysis, residual analysis. The residual analysis is helpful for checking the assumptions of regression model. Okay, so this is what finally that means a data analytic person should know before developing a regression model. So regression model is a bivariate if you have only two variables. If you have more number of independent variables, then it becomes a multivariate model. Okay, most commonly used model. Most commonly, y should be dependent variable should be metric data or interval data, and the explanatory variables can be either the interval or metric data or can be even categorical data. So that all those things I explained in the last class. If you have the categorical variable as a independent variable, then when you go for using the SPSS, okay, so you have to convert that categorical variable into, suppose if you have more than two levels or two classes, then you have to go for dummy variable technique. So that is also explained. So that is about the complete regression model, most commonly used regression model. Most of the students, like you people only, you are going to use it in your project. Okay, in the upcoming project, you are supposed to submit under the guidance of some faculty, you will be allotted. So there, normally, most of the time you will get the data of this type and you will go for predictive analytics. So predictive analysis, you can go for developing regression model or some more models also. Regression is the most common and easy also. Okay, so that is about the regression model. So in the predictive data analytics, predictive data course, here we have first one is simple linear and a multiple linear regression model. Now we have to move further other types of models. The next, the model, what I am going to discuss with you now is the discriminant model. Discriminant model. This is a discrimination. Discriminant model. Okay. So the next model would be discriminant model. That is a discriminant analysis. So we did first one, regression analysis, then now the discriminant analysis. What is this discriminant analysis? Means discriminating between the two. In other words, finding the group membership, whether the individual or an object belong to the one category or the other category. Means either to one group or other group. Okay, very simple. When you take a set of students, okay, so when they are entering the classroom one by one, so what we'll do, we make it two groups. One is a girl, the another one is a boy. So simply what we want to distribute these students to two different groups. So a student entered as a girl, we'll ask her to go to this group. If a student entered as a boy, we'll ask him to go to another group. That is a boys group. Very simple. That means we are classifying. The arrived students, we are classified into two groups. Same thing here also, we have to classify. Okay. See, for example, if you take another, this one, the customer, when you go for shopping in the mall, okay, or anywhere, departmental store, wherever, most of the time in a departmental store, mall, etc. So he can be considered as a buyer or a non-buyer. Okay, so he will go and he will purchase the item. Sometimes he won't do any purchase, simply he will go for window shopping and he will come back. So whoever is the interested person, a key person, a decision maker, he would like to know whether the individual is a buyer or a non-buyer in our mall. So that means it is able to help him. What percentage of people are buyers, what percentage of people are a non-buyer. So he can plan accordingly. Simply we see that when in a mall and all, huge rush and all. It is not that everybody is buying there. Or buying, if at all, what they are buying. Is what the data analysis every mall have to do, no? So most of the time in a malls and all, you can see that when there will be huge rush for the restaurant or the chart items, etc., more than purchase the jewelries or cosmetics or any other apparels or anything, correct? So that is what we see. So what percentage of people, where we have the more sales. So many analysis they will do nowadays. So, and they can accordingly, they can plan what type of customers are coming, means whether the medium income level or a high level society people, like a high income level people or a poor people. So what type of people are coming to our mall, etc. Where is that located? So many things are matters, you know. So the people can use the data analysis nowadays. So that's why they appoint the people or they take the help of the outsource agency, or they may have their own in-house agency to understand all this information and to convert it into some model, prediction model, etc. So one such model, the next one is the discriminating. So classifying a customer or whoever comes to a mall as a buyer or a non-buyer. Okay, many ways we can do. Or if you take let us say the bank, if you would like to know that the bank's performance, normally we can classify in our country that the banks are commercial banks, the private banks and the nationalized banks, that is okay. Apart from that, some of the banks are really doing extremely good. Their share prices are like anything. Some of the banks are not doing well, even though they are under the government control. Their share prices are very less. So normally we get confused. So why it is happening? That means you would like to classify the performance of these banks. Okay. So there are various methods are there to understand the performance of the bank. So one such method is that you can use a discriminant model. We can classify the banks based on the volume, the asset size, based on the number of branches they have. Okay. So like that way, you can classify whether it belongs to a larger category bank or a small category bank. See, for example, if we take a ICICI, HDFC, generally we know SBI and all have the huge network and their assets also very high. Their profit also, quarterly profit, when you see that one, that is also high. So, whereas if you take some other nationalized bank, maybe less. So what are the parameters which influences the bank to become a high performance bank? Means a large bank or a small bank. So we can classify. So we can use this discriminant model. Another example, I would say, nowadays the people are using the internet. Okay. So we can classify the users. Some people are using hours together. That means all the time or large number of hours in a day they will use this internet. That means in surfing you can say. So internet either at home or in the somewhere or in the office wherever. And some people you can consider not too many hours. That only some limited period they are using the internet. So I would like to classify these customers, means these people, high users of internet, low users of internet. I want to group them. Suppose if I know you, so where you come, which category you will come, whether you come under the high user or whether it is low user. Why you are using the internet first of all? For different reasons. Somebody wants to make a social relationship, means to interact with the other people. Some people are using it for video games. Some people are using it for just chatting. Some people are using for a sports awareness. So different reasons are there, Some people for movies, etc. So we can classify why the people are using the internet. Okay. So some people may be using for education purpose. So which of them influences more to classify he is a high user of the network, internet, or a low user of the network, internet. So how to classify an object? That means a person, high user or low user. We can use a discriminant model. So like that way, wherever you want to put into two categories, two groups. If you make only two groups, like what I said, large bank, small bank, high user, low user, buyer or a non-buyer, only two groups, that is called as a dichotomous group. But sometimes we may have to do more than two groups also, 3 groups, 4 groups, etc. In such cases, we call it as multiple discriminant model. That means we are going to have the multiple groups. So we are classifying the individual or object into their respective groups. So how to differentiate that? How to make that individual or a new object into any one of these groups? For that we can use the discriminant model. So it is another one more multivariate model. So here in the multivariate model, again, what is the general relationship of any model? Dependent variable y with the help of the set of independent variables. How do you write a model generally? Regression we have seen. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 etc. We write it. Okay. There in the regression model, the dependent variable y supposed to be interval scale or the ratio data, ratio scale. Not ordinal or nominal. Nominal means what? Like classification. Presence or absence, like male or female, or large or small. Okay. High user or a low user. What I said like that. But they are the nominal data. They are not the interval or ratio data. Whereas in a discriminant model, the dependent variable value must be categorical. Huh? Marketing? Segregating. We can consider many things. We can consider the grouping, classification we are doing on the basis of a different explanatory variable. Okay, different ways. That's what I said, why the people are becoming a high user? All the time they are playing in the game, That's why they are continuously using the hours together internet. So classified as a high user of internet. Whereas the other person only limited just for sending the mail, just simply seeing some WhatsApp messages or any other. So he can be considered a low group, means low user of the internet. So we can classify the person, we require which of the variable influences more to classify either into first group or into the second group. So the dependent variable y must be here considered a categorical variable, whereas in earlier regression model, it was not the case. They supposed to be interval or ratio data. So here dependent variable must be two values only. Y should be either 0 or 1. Even you have the dichotomous. If you have more than 2, then y can take the value like 1, 2, 3, 4, if there are 4 groups. No, the concept is different. Just I am explaining. More values means it doesn't go to regression model. Groups are more. Groups are more doesn't mean that it becomes a regression model. Regression model, the variable is different. So that is what the purpose of discriminant analysis. So it is a discrimination. So look at the slides now. I explained so far, whatever I explained so far, the same thing. Once again, let us go. Discriminant analysis captures the relationship between a multiple independent variables, that is the explanatory variable, and a categorical dependent variable. So the dependent variable y must be nominal scale, nominal data. So in the usual multivariate way only, by forming a composite of independent variables. Means in the similar way of regression model, we can also write down the discriminant model. I'll show you in the next slide. So discriminant analysis is used to predict the group membership, whether a object belongs to the first group, second group, etc. So this technique is used to classify what I explained so far. Again, same thing, individual objects into one of the alternative groups on the basis of the set of predictor variables. Now, the discriminant analysis of different types. Two group discriminant analysis. That is what I said, dichotomous. Only two groups. Okay, that group or this group. If you have the multiple, more than two groups, it is a multiple discriminant analysis. I explained already. Objectives. What are the objectives? Why we have to go for discriminant analysis? Okay, look at this one. To find a linear combination of variables that discriminate between categories of dependent variable in the best possible manner. So I would like to know that how the independent variables, the different linear combination of these variables will classify the individual into one of the groups. Okay, in what best way the variable, like when you want to classify a person into high user of internet or a low user of internet, what are the important variables? Okay, so that is what you are going to learn in the first objective. Second one, to find out which independent variables are relatively better in discriminating, like high user and low users. Again, I will come into the same thing. Which variable is more important to classify that he is a high user of internet? For example, people are using, suppose, more video games. So video games through the internet is a high important variable to classify he is a high user. So like that way. To determine the statistical significance of the discriminant function. This is similar like a multiple regression only. Next one, to develop the procedure for assigning a new object. Okay, to develop the procedure for assigning new objects, firms or individuals to one of the groups. And the last one, to evaluate the accuracy of classification. So we can't say that our model will able to classify with 100% accuracy. Okay, to what extent our developed model will able to classify individual either into first group or into second group. So that is what the objectives we have to go for discriminant analysis. Uses of discriminant. Where are we going to use this discriminant function? So in the scale construction, first one, that is a discriminant analysis used to identify the variables, statements that are discriminating and on which people with a diverse views will respond differently. So when the people have a different views, they are responding in a different way. For example, like now the election is going on in Karnataka, correct? Now, and for different parties, the people have a different views, different mindsets, okay, different ideas. So, to go for a scale construction, we can use this discriminant model when they have the diverse views. So, for example, if there is a cat consensus for that, they can. We can. If you have the sufficient data, suppose if he is, okay, person, some belong to one, this one, so he is going to vote for this group or that group. That means whether he belongs to this side or that side. But we must have a sufficient information. What makes him to go to this group? What makes him to go to this group? If you have the data previously, using that sample data, we can develop a model, and that model can be utilized for the other ways, I mean for other people also. See, whenever you go for a model developing, that is what the meaning, as I said. First, we develop a model with the help of some sample data. Let us say some 100 observations, we develop a model. What about the 101st observation if he comes? Whether he belongs to this group or that group. Okay, for that we go for validating the model. Means we use the developed model for the information of that 101st person. That 101st person will give the views, okay, on a different parameter, different variables. And this model, after that, it will able to classify, he can be belong to this group or to other group. So developing the model, validating the model. So what we are doing is like that way. Next, segment discrimination. That is what we are going to discuss now. So what I am discussing classification is a segment discrimination. So that means a demographic key variables which differentiates between a potentially successful and unsuccessful salesman. So if you want to classify the salespeople as a successful or unsuccessful, so you can use this discriminant model. With sufficient information, you can develop a model. Later on, you can use that one. Company can use it. Whether this person, if you have the same information on him, can he become a successful salesman or not? Let us say based on his attitude, his patience, his way of talking, his knowledge about the product, okay, his passion about the selling. So, which of them are important to classify? You can choose. So, if the output is the newly added salesperson has all these qualities, to what extent he has this quality, if you are able to quantify the data, then you can use the model and you can classify he is going to be successful in future, he is not going to be successful. So, that is a possibility is there. Similarly, next second example, key variables which differentiates between the users and non-users of a product. What I said example. Economic and psychographic variables. They are asking now, okay. Where is the prediction interval in the graph? I showed it already. I have taken the new, okay, I asked the long button. Sorry, I didn't see your question. Just now I highlighted, I have seen. Okay, I'll come back to that later, okay? I'll come back to that later and I'll continue with this model. So the third example would be, that is the economic and psychographic variables which differentiates between price sensitive and non-price sensitive customers. You can classify, no? So when you go for mall or wherever, the customers, how they behave. Some people don't bother about the money. They don't bother about the price. So whatever the price they will buy. Some people are very important for them is a price. So they are price sensitive. So you can classify whether this person, the price sensitive customer is not a price sensitive customer. Accordingly, the mall or whoever can changes, okay. Suppose if you are price sensitive, then they think what changes can be made to attract the customer and to keep him as a customer, etc. So please stop, okay. Something irritating all the time, more important. So it looks for me something, we'll go back then. Hardly two are there now. They are only listening that side. So it deviates. So suddenly we forget, oh, these people are not listening. Please for some more time. Okay. So this is an example. So some more examples I showed later. So the next is what? The next type. There is a classification. The third type of use of discriminatory is perceptual mapping. So what is that perceptual mapping? This will help to create attribute-based spatial maps of the respondent's mental positioning of brand. Okay, how they are branding, how they are having the mental positions of the different brand. Let us say that the mobile phone. Different brands are available. For example, Redmi is there, Oppo is there, Samsung is there, other things are there. How their mental position for that one? That means red meat nowadays is very popular. So it comes immediately as the first position first. The next one is what? Let us say Oppo. Another one is Vivo. Like that way. So there again we can use this discriminant function. Okay, it's a classification only, but a little bit change. That is called the perceptual mapping. So discriminant model is useful there also. Mapping. Okay. Look at this one. That is to determine that the attribute that are valued the respondent to for the unique selling proposition of a certain brand. Okay. Examples are given. So these are the different types, uses of discriminant model. So now I given the example. Look at this one. Further, for classification purpose, a wool manufacturer wants to know the characteristics of the fiber that differentiate between prospective buyer and non-buyers of the product. So it is a wool manufacturer. Any product, this is one example I have taken. So that that means the wool buyers. Okay. So what they expect from this manufacturer? Durability of the wool, the lightness in the weight of the wool, the low investment in the conversion facilities where they are converting, rot resistance. Okay. That means from that. So these are the important factors for a buyer to buy that wool. So we can classify. So they are giving some score. Some people say that durability is for them is more important. Some people say no, more than durability for me, lightness in the weight is more important. So different information they will provide in the form of some scale points. Okay. Using that points, using that data, we may develop a model and we can classify whether a customer belongs to a buyer or non-buyer of that wool product. So again, that is a discrimination. This is not a perceptual, it is a classification. We are classifying. So here my concentration is about classification. There are three types I told you, but I am discussing here the most, this is nothing but a classification only. This is a grouping. Grouping a person. See, if I have some 40 people, okay, some 20 people are buyers and 20 people are not buyers. We know already. And now I am taking the score from them. What they say about the durability, lightness, low investment, rot resistance. So using the data of 40 people, I will develop a model that will help to classify these 40 people. See, for example, first person is a buyer. Now he has given some information. I am putting that information in the model, and I'll use some method. You will come to know that in the coming subsequent slides. That how to classify, etc., to one group or the other group. So we have some standard set value, benchmark value. We compare this with that benchmark value. And suppose if this value is more than the benchmark value, he is considered as a buyer group. And if he is lesser than that benchmark value, we consider him as a not a buyer group. Okay. So originally what is he? He is a buyer. Okay. Suppose if through that comparing that actual value and the benchmark value, if I able to classify that buyer into buyer only, so that means my model is very good. It is classifying buyer into which group? Same group only it is putting. Suppose if instead of keeping the buyer into buyer group only, suppose if it classify as a non-buyer, because it understands the data and accordingly it says, model, then what we can say, it is a misclassification. That means the model is not perfectly classifying. It may happen, but as I said that we are not expecting 100% accuracy in our classification. Suppose if 20 customers are there, suppose if 18 customers are correctly classified and only 2 people are wrongly classified as non-buyer. Similarly, other way also, then model is very good. You can't expect 100% perfection in classification. High amount of degree of accuracy is also enough. So that is what the discriminant model.
So big data is very popular, right?
That is another type. This is not a big data. This is developing a model. See, nowadays big data means what? Big data is based on the volume, velocity, etc. Correct. So I am not discussing about the big data. In the big data may be a part of this one. It is not entirely the big data. So here we are teaching the basic traditional models of regression, means multivariate. Like these are the traditional models people are using from that time only. Okay. So now when the more complexity is added in the data, like we call it as a big data, and we have the artificial intelligence, many things are there to understand, analyze and understand the data set and to come out with some different models. Okay. These are some traditional. We are not going to that advance of big data and all. So this is a part of the big data analysis, not completely. Okay. So big data analysis is something different. It may have even qualitative data, quantitative data, analysis method is maybe different. Of course, we have the tools, techniques and all, but we are restricting our study here only to this level. Okay, you can extend that one, no problem. So another example I am taking, suppose the admission in our university for any course, let us say MBA course, how they are making admission based on the written test score of a student, so group discussion score and then the interview score. Clear? So now we can classify that whether the person, okay, he is aspiring for MBA in our university, can be selected or not be selected, whether he comes under the first group or in the second group. So we can use the discriminant model, means for pass or fail. Next one, let us say that the SBI, State Bank of India wants to ascertain the credit rating of the consumers as a high risk or a low risk. So nowadays is very important. You know that people are becoming more defaulters now. So default payment and the low risk. Correct. How, on what basis? Generally, the banks will say, these are the simple examples I have taken. Maybe many more explanatory variable to decide a high risk or a low risk. They normally when they go, what is your income? So what is your income level? Age, whether the young age or old age, etc. Years of marriage. May not be important, but I have taken as one of the influential variable. But at the end, we have to check through the model whether it is also influential or not. Years of marriage. Some example I have given. Many more examples to classify the salesperson, as I said, the successful or a non-successful. Take the last one. To classify the high or low user of social networking, that is the internet site, among the students or among the public, you can say whatever. What are the important variables to classify high or low user? Time spent daily on a networking site during the weekdays. How much time they are spending networking sites during the weekend. Then, for what reason they are using? For messaging or chatting. Some people are using to make a new friend. So some people are using to promote the events or information. Some people using the blogging. Some people for news update, games, education, etc. So based on all these information, we can classify. Then we can also identify which of them are more important or influential in classifying a high user or a low user. So that is the advantage of this. Yes.
Is this related to that? Can we relate to this, for example, in a single slide or something about perception? Can we relate this to that?
That is what level? Analytica is there. They are breaching that code of some conduct, their ethics and all. They have given it distributed. What type of data is given is not disclosed. They are saying that only the data has been shared. What type of data? Facebook data, and it became like it's to for the help the one particular party. It is not related to business, I believe. Okay. So that means to get some information about the people like belonging to different age group or perhaps different caste or different income level or something. So that based on that, the political parties wanted to put their different strategies. So they have taken the help. That is what the Analytica I heard. I mean, what I understand, not as a business problem. So, in what way you have to take? See, that Analytica information sharing means it is not directly as a mapping like that one. This is a traditional model. Huh.
Liking a particular page,
Huh.
liking a particular comment.
Huh.
So based on that, they classify users. So that is if you start classifying as a
Huh. See, that's what. It can be used. That's what I said, It can be used for that one. Which one is the more influential? I have taken how many variables there? So many variables are taken to classify him as a high user or by low user. Okay. Which of them are more important? That we have to through study. Then suppose if it comes like messaging, what you said, if it appears, okay, that is the more important, then we can think, okay, people are looking for this type of to collect the information who are regularly going to that site and seeing and all. So that is different. No, no, my logic is here is not like that. How you can classify individual into this group or that group? Of course, you can use it. Analytica, not Analytica. Analytica is provided the data, but that political party, whichever, they have used the data to analyze like this way. Strategize that one. See, suppose, okay, these are the things he will vote for this party. Here are the things he will vote for this party with their perception. Okay, so how to attract something like that one? I don't know because I didn't go through that one. I understood only. They didn't say that what way, why they are used at all. They are taking only the log. Okay, so that is about the discriminant model applications, which are the areas. Now let us go to the next one, assumptions in discriminant analysis. That means when you go for developing a model, similar like a regression model, what are the assumptions to be satisfied? You cannot simply directly use a discriminant model for classifying. Okay. First assumption is what? All the predictors must be independent. That means the explanatory variables. Like when you go for classifying that high user and low users in the previous example, all the independent variable like a time spent on weekdays, time spent on weekends, messaging or chatting, blogging, these are all independent variables. They must be independent. So that is the assumption. How to check that independence? There is method. Okay, that means there should be no multicollinearity. That is the meaning of independence. Suppose if you have all these variables are highly correlated, then why do you want to, how can you differentiate the variable? We expect no multicollinearity. If the time spent on the weekend, weekdays, both are highly correlated, then there is no need of keeping these two as a separate variable. Suppose the same people who are using the weekdays, the same percentage of people are the same people who are using even a weekends also, then why you want to have the separate variable saying that the time spent on weekdays, time spent on weekdays? You can take any one of them because both of them are sharing the same information. So that is what the problem of multicollinearity. So what we expect, all our defined independent variables must be independent. That means the predictors, independent variables, must be independent. There should be no multicollinearity. Second assumption, predictor variables should be normally distributed, similar like a multiple regression. Okay, so it is an extension of that one. The predictor variables must be normally distributed. It is a normality assumption. There should be absence of outliers. So that you know outliers means what? They're not belonging to that area in that relevant group. So they are considered outlier. Clear? So outlier obviously hamper the model. It won't. So outliers should not be there. It will be there. We have to identify that one. There is a small difference between how to. If the outliers are there in the model, okay, outliers are there in the model, then we can remove that one. See, when you go for classifying the high user or non-user, low user of that one. Suppose if a person is not at all using the internet, okay, and you are considered once in a while he is using the internet, not like this one, then he is obviously an outlier only. So using his information, you cannot classify that there is a high user or a low user. So outlier. What we can do in that case is, you can ignore those values. Like you can remove those data in the model building. Box plot will help you only to identify the variation. That is the initial phase. These are the box plot is used to check the normality of the data. Box plot, the main purpose is normality. How the values are distributed. Outliers you can check using the normality, that box plot also. There is a thing. So there is some rule there, no? You can use a box plot to check the outliers in the data. Then sample observation should be at least 5 times of the number of variables. That is what is a minimum requirement. See, for example, you are independent like high and low users. I have chosen around, I think around 8 variables, 8 to 10, let us say. If there are 10 variables, then minimum how many observations you must take, how many sample units you must have in your model building, 5 times of that. That means 50 observations. Just by the help of the 10 people or 10 customers, you cannot able to classify or you cannot develop a model. You must have the sufficient sample data, sufficient sample size. What is the sufficient? The minimum requirement is given. The sample data must be at least 5 times of the number of variables. If it is a more number of variables, more number of units, it is a very good. If the sample is large, for all the state is always good, Say, for example, the election results are coming, pre-poll, exit survey, something, etc. So if they able to interview across the state so many people, let us say that around large sample size, then you can understand the accuracy of that their opinion poll results. Correct. So because they have conducted a large sample, so many sample units they have chosen, they have taken so many, they will explain, during that process of sampling and all. So if the large sample is there, we can understand the accuracy of that one. But just by interviewing some 100 people here and there, is it possible to predict that, okay, this party is going to win so many seats, this party is going to so many seats, this much of changes will happen, etc. with the able of 100 units when the 6 people, around 4 crore people are going to vote? No meaning. So that's what, the sample stages must be very large. All pairs of predictor variables must be linear. That means the x1, x2, etc. many variables, they must be linear related. And last one is the multicollinearity. So it is same as similar like a first problem only. When you say that the predictor is independent, it means that the variables are uncorrelated, or when the variables are no relationship, that is a multicollinearity only. It's one and the same, highlighted separately. So what do we understand? The different uses of multiple regression, discriminant analysis. Okay. The next one is assumption the discriminant model. Okay. Types of the discriminant model, the uses of discriminant model, and then the assumption. So now let us go for theoretical understanding. Conceptually we have understood now. Let us go with the mathematical understanding of that model. So the general model of the discriminant is same thing like a regression only. Y is equal to B0 plus beta, B1 x1 plus B2 x2, etc. So there are k independent variables, only y dependent variable y. Y should be what? Categorical variable. That is a important thing. X are the independent variables. Or you can also write the discriminant function like this way. Discriminant coefficient 1 into IV means independent variable 1 plus discriminant coefficient 2 into independent variable 2, etc. You can write different way. So most commonly used as B0, B1, x1, B2, x2, etc. The usual regression, discriminant model function. Now, how to estimate these coefficients B0, B1, B2, B3, etc. from the sample data? That is what called as a fitting of discriminant model. So in the regression model also, estimation, that is nothing but a fitting of the model means estimation of this beta, B0, B1, B2, B3, etc. from the sample data. So what method applied? So in the regression model, we applied the ordinary least squares method. So ordinary least squares method means minimization of the error sum of square, residual sum of squares. So residual means you know that the difference between the actual value and the estimated value, y minus y cap. So that method I already explained in the previous class. Okay. Now, here in the discriminant model, what is that method is useful or used to estimate the parameter? The coefficients are now called as a discriminant coefficient, whereas in the earlier regression model, we used to call them as regression coefficient. For each case, the coefficient for an independent variable, that is like a B1, B2, etc., is multiplied by the case score, that is nothing but the variable, x1, x2, etc., on that variable. These products are summed, means added. The same thing, model. I am giving the explanation of the model. And added to the constant, and the result is called the discriminant score. That means when you put the value for B0, B1, B2, etc., along with the values of x1, x2, etc. Then you will get the value of y. That is called the discriminant score. That is called the discriminant score. Okay. So based on the discriminant score, we are going to classify an individual or an object either belong to the first group or second group. So that discriminant score should be compared with what? Some benchmark value, standard cutoff score. So what should be the cutoff score to classify whether belong to a first group or second group? We'll come to know in the coming slide. Okay, how to choose the cutoff value, benchmark value. See, from the discriminant scores can be derived predicted probabilities. That means having the discriminant score y values, we can find the probabilities. What does it mean? What is the probability that this customer is going to be a buyer? What is the probability this customer is not going to be a buyer? Who is interested in that? Normally the decision maker or a manager, whoever concerned person in the mall, let us say, would like to find out. Suppose if he is a person coming to our mall, what is the probability he is going to buy the product? What is the probability he is not going to product? So higher the probability, what does it mean? It is almost sure he is going to buy. So lesser the probability will give the information to the manager as what? He is not likely to buy the product from our mall or from our company. Okay. So the probabilities, how can we calculate? Using the discriminant score. But this was not there in the regression model. In the regression model, we are not going for calculating the probability. But here we are finding the probabilities. For what reason? To know the chance of an individual object belonging to one of the groups, either the first group or the second. So that is what the second thing. Then the third important point here is the eigenvalue. That is a mathematical term. So let us not too much worry about that one, but just give an explanation. What is the meaning of the eigenvalue? How to calculate that? To calculate the eigenvalue, you must recollect, you must remember the ANOVA table of the regression model. Analysis of variance table of the regression. Okay, that ANOVA table is useful in the regression model for overall significance of the model. Whether the model is good or not, to check that we can use the ANOVA table. So in the ANOVA table, there will be different columns. The source of variation, degrees of freedom, sum of squares, mean sum of squares, F ratio, F calculated, etc. Under the sum of ratios, we are going to have due to regression, due to error, due to total, etc. So when you take the ratios of those two types of errors, that is called the eigenvalue. What is that? It is a ratio between the group sum of squares to the within group sum of squares. So you should imagine what is the ANOVA table or go back to the afterwards, okay, multiple regression model, go through with the ANOVA table, you will come to know that where is the sum of squares, where is the mean sum of squares. So if you take the ratio of those two different types of sum of squares, group sum of squares and within group sum of squares, so you will get this eigenvalue. So what is the purpose of using the eigenvalue? Higher the eigenvalue, the model is better. Suppose if your eigenvalue is more value, higher value, that means your discriminant model which is used or which is being useful for classifying into one of the groups is very good model. We can trust that model. That is the meaning. So eigenvalue is nothing but equivalently saying as a F ratio only of ANOVA table. Okay, that's what I said, that you can go back to ANOVA and check what is F. And it's the statistic on which discriminant analysis impact pivots, whether it's significant or not. So what did I do now? I explained what is the meaning of the regression model. Estimation means what? Cutoff discriminant score means what? Group membership probability means what, etc. Now we have to go for what? How to estimate the parameters. That means from the sample data, how to estimate this B0, B1, B2, etc. So in the regression model, we estimated, as I said, by using method of least squares, that is ordinary least squares, minimizing the error sum of squares. In the discriminant model, how to estimate this beta naught, sorry, B naught, B1, B2, etc. So for that, we have the two methods. Method 1, method 2. Okay. So what is the first method? Method 1. It is not an ordinary least squares method. Method is a different method here. The discriminant scores can be divided into two groups. And the mean discriminant score can be calculated for each group. The group means on the composite variable are known as the centroid. So what does it mean? Look here. In our case, I have taken one group as a Bayer group, another group as a non-Bayer group. Now you take the average value of the Bayer group. You take the average value of the non-Bayer group based on the information they are giving. That means the score. They are giving the score on the, different variables. Okay. Like what I told you, durability, rot resistance, conversion, etc. Suppose, if I take the same example, they are giving the 5-point scale in Likert scale data. That data, numerical values, you have to take average of the Bayer group, average of the non-Bayer group. Okay. Then you take the mean of these two groups. So that is called the group centroids. Two different groups are there. You have to take the mean of that. That is called the centroids. The coefficients are estimated so that the distance between the centroids is maximized. So the method we are applying in the discriminant model to estimate the beta naught, B1, B2, etc. is nothing but maximizing the distance between the two centroids. So you should understand clearly what is the meaning of centroid. That is the first method. What is the second method? The second method is the principle. I explained there, centroid means what? It is there. Centroid is nothing but what I explained. You are taking the mean, average value of the first group, average value of the second group. Then they come, See, discriminant scores can be derived. Discriminant scores means what? The y values. These y values, for a different values of x, we are getting the y values. Correct? So, the discriminant values, okay. Discriminant scores, go through the sentence clearly, I think you'll be able to understand, can be divided into two groups. We are getting the discriminant scores of individuals. That means the Bayer group discriminant score, non-Bayer group discriminant score we are getting. So it can be divided into two groups. And then the mean discriminant score, first group mean discriminant, then the second group mean discriminant can be calculated. That's what the meaning. Now, you have to take the group mean on the composite variable. What is the meaning of that? You can take the average of these two means. So that is what is called the centroid. Second method is what? Another method. The principle can also be stated in terms of eigenvalues. Okay. So here the predictor is nothing but the independent variable, explanatory variable. Like, so in classifying the high user or a low user of the internet, what I have taken as a predictor? The time spent by a person on a weekdays, time spent by a person on a weekend, and they are using it for charting, using it for blocking, using it for education purpose. These are the explanatory variables, predictor, which will help you to predict whether individual belongs to this group or another group. Here again the Bayer and non-Bayer case. Okay. So what are the predictor? Durability is a predictor. that earlier going back to example, rot resistance, conversion, low investment. These are the different predictors to help classifying buyer and non-buyer. So that is what the predictor. I hope you understood. So the second method is what? The principle can also be stated in terms of eigenvalues. We already understood just now what is the eigenvalue. Discriminant coefficients are chosen. That means discriminant coefficients means immediately should come to mind B0, B1, B2, etc. Okay, estimated that maximize the eigenvalue of the composite variable. So what is eigenvalue? The ratio between the group summa squares to within group summa square, between group summa squares to within group summa square. That value has to be maximized. So that is what the method here. So when you maximize that, the eigenvalue for the composite value, that is the ratio between the group summa squares to within group summa square. And through that, if you estimate that B0, B1, etc., that is the second method, maximizing the eigenvalue. Whereas the earlier method, maximizing the distance between the centroid. So two different methods. In the SPSS, we have both the methods options. We can use any method to estimate the parameters of the model. Okay. Next, after the estimation, what we do? We write the model. Y is equal to so and so, we write down. Now the important stage is cutoff score. Means we have to classify now whether a individual belongs to buyer category or a non-buyer category. That is, cutoff score is a benchmark value. So for a first person, there is a value, discriminant score value is there. Now where to classify him? Whether into buyer group or a non-buyer group. So for that we have to use a cutoff score. How to calculate that benchmark cutoff score value? There are two cases. Suppose in your classification, if there are equal number of observations. Okay. See, for example, buyer there are 20, non-buyers also 20, totally 40 in your analysis, equally distributed. Then how to find the cutoff score? Look at this one. The cutoff score is usually the midpoint of the mean discriminant scores. That is, the mean discriminant score is the centroid value. That is, first group, the buyer group average value. Clear? Non-buyer group average value. The cutoff score is the midpoint of the mean discriminant scores of the two groups. In case of two groups, discriminant analysis provided the size of the samples in the two groups are same. That is what I said. That means just you take the average of the two discriminant scores. That's all. You will get the cutoff score. No. Centroid is what? It is the mean value. Two groups. Two groups. No. Centroid is for each group the mean value. Centroid is for each group the mean value is a centroid. Okay. Cutoff score means we are taking the mean values of both the groups. We are calculating equally. Suppose if the sample sizes are different, let us say that there are 30 buyers and 10 non-buyers before doing the discriminant model. So N1 is 30, N2 is 30, and we have the discriminant score for the buyer group as a Y1 bar. Look at the formula. Y2 bar is a average discriminant for the non-buyer group. Then how to calculate the cutoff score? Formula is this one. N2 Y1 bar plus N1 Y bar 2 divided by N1 plus N2. If it is the same, just simply take the average. If the sample sizes are not same, then cutoff score can be calculated using this formula. Okay, where Y1 bar and Y bar 2 is nothing but the mean discriminant score. That mean discriminant score is nothing but the centroid. See, don't get confused with the term centroid. Centroid is nothing but the mean discriminant score of the first group, second group. Okay, the cutoff score can be used to classify any new data point into one of the groups. So as I said now, suppose the 41st customer will come. He will get all the data about him, information. We'll put his data into that model. Then we'll get the Y value. That is a discriminant score. Now you use a cutoff score. Suppose if his value is more than the cutoff value, put him into one group, buyer group. If his value is lesser than that one, you put him into the second group, non-buyer. Okay. So that is what the purpose of using the discriminant model. And many more things are there, like a correlation matrix is the next one. Yes. To classify whether to class cutoff score is only one value. That is used to classify whether person belongs to first group or the second group. Okay, that's all. So correlation matrix is there next one. What is that? Correlation matrix for the entire predictor variables. Means not for the y. You are taking that x1, x2, etc. No? So that variable helps to detect the problem of multicollinearity. As I said, the variables must be no multicollinearity. The variables must be different. If the time spent on weekdays, time spent on weekends, if both of them are highly correlated, that means the same people are using on both the time, same amount of time, weekends as well as weekdays. There is no point using a separate variable. One of them would have been enough. So that is the case of multicollinearity. So we can use that correlation matrix to check which of the variables are highly associated with the other variable, correlated. So high correlation between a pair of predictor variables indicates that both the variables in that particular pair share a large amount of common shared variance and might reflect the same attribute. Therefore, there is no need to take both as a different variable. In such case, one of the variables, two variables could be eliminated for further analysis. That's what I explained just now. The same thing. Then the canonical correlation is there. It is a simple correlation between the discriminant score and the coded values of the groups. So again, there is another type of correlation between the y values and the coded value, means between x1. Earlier correlation is between x1 and x2, x1 and x3, etc. Now the correlation between y and x1, y and x2, y and x3, etc. That is known as the canonical correlation. So what it will help? It will help you to identify what percentage of variation in the dependent variable explained by these separate independent variables. So that is the square of the canonical. Similar like R squared value of the multiple regression. Similar like the R squared value of the multiple regression. So that is about the discriminant model. Okay, there are many more things I think can continue in the next class. Okay, so I stop at this stage. So just you can go back, and it is already there in the here. If you want to copy this information, slides and all, it is there in the desktop itself. Okay. I think he must have sent it already. So it is there. You can see that one. You can, if you want, you can copy it here. PDA entire course. So you can copy, and all these slides are available. Otherwise, I already told Hussein to share this. So you can go through, and I'll continue. So concept, what you should understand is that the difference between the multiple regression, the discriminant, and why we are using. And next level is showing through the SPSS now. Okay, I have explained the concept. We have to now do one or two practical examples using the SPSS. How to run the SPSS, how to understand those numerical values. Okay. Next class. Last class also used the SPSS, but for multiple regression, I already done. Now for a discriminant model, I'll take that model, the SPSS data in the next class. Through the SPSS, how to do the discriminant model. Okay. Assignments, I think, is given or not yet given? Huh? Okay, thank you, and good night. I'll stop recording.